Today we're going to continue practicing graphing linear inequalities. And our example inequalities will be written in standard form. So let's get started. So I have broken down the process of graphing linear inequalities into 5 steps. And the first step is to rewrite the inequality as an equation. And then we're going to graph the equation. Because this process starts with the skills we learn to graph linear equations, it is quite common for this topic to be discussed in a unit on linear equations. But I've decided to have a separate unit on linear inequalities. One reason is because linear inequations is such a huge topic. But also because as we start looking at linear inequalities, it serves as a nice review of linear equations. So steps 1 and step 2, we will use those same skills we used with linear equations. Now how we actually draw the line, whether the line is solid or dashed, will be based on whether or not equality is included. So if we have less than or equal to or greater than or equal to, we'll include a solid line, indicating that all the points on the line itself are included as part of the solution. And if we have a less than or greater than sign, so we do not have or equal to as a possibility, then that line is going to be dashed, indicating that the points on the line are not included in the solution. So that boundary line that we drew separates the graph into 2 regions. And we need to determine which one of those regions is correct, and we do this by testing a point in each region. And then once we determine which region is correct, we shade that entire region. And every point in that region is a solution to the inequality. So let's practice a few. In today's lesson, our inequalities are going to be written in standard form. As a review, standard form for an equation is ax plus by equal to c, where a and b and c are all constants. So the first step for graphing linear inequalities is to rewrite this as an equation. So this is 3x plus 4y equal to 12. We're not magically changing anything, we're just rewriting it as an equation to help with graphing. Now how you graph this line is up to you, but one possible way of graphing it is to find both the x-intercept and the y-intercept. With those 2 points, we can then connect the dots to get our line. So to find the y-intercept, we set x equal to 0, and we solve the equation. So this is 3 times x, so 3 times 0, plus 4y equal to 12. This gives us 0 plus 4y equal to 12. We now have 4y equal to 12, and then dividing both sides by 4, we get y equal to 3. So our y-intercept is the point 0, 3. And we can graph that point. Now let's find the x-intercept. So the x-intercept is where y is equal to 0. So now we have 3x plus 4 times y, so this is 4 times 0 equal to 12. We have 3x plus 0 equal to 12. 3x equal to 12. And then dividing both sides by 3, this gives us x equal to 4. And our x-intercept is 4, 0. And we can plot that point. We now have 2 points, so we can draw our line. Do we draw a solid line or a dashed line? We make that decision based on the type of inequality we have. We do have the r equal to. This is greater than r equal to. So that means we're going to have a solid line. So every point that's on this line is a solution to this inequality. So we have our boundary line, and our graph is divided into two regions. We need to determine which side of the line contains all the solutions. And we do that by testing a random point on one side and a random point on the other side. It does not matter which point you pick in each region. As long as the point is not on this line, you can use it. Now, since we're all somewhat lazy and we want to try to do the easiest thing possible, if 0, 0 is not on the line, go ahead and select that point. So let's test the origin 0, 0. And we're going to plug this back into the inequality. So we have 3 times 0 plus 4 times 0 greater than or equal to 12. So we have 0 plus 0 greater than or equal to 12. 0 greater than or equal to 12. And that's not true. Now, if this point is not true, that means none of the points on this side are a solution to the inequality. But let's make sure and check a point on the other side of this boundary line. Let's try 0, 4. This is on the y-axis, but it is not on the boundary line. So we have the point 0, 4. This is 3 times 0 plus 4 times 4 greater than or equal to 12. So we have 0 plus 16 greater than or equal to 12. 16 greater than or equal to 12. And that's a true statement. So we're going to shade in this region of our graph. Right now I'm just drawing lines to show it. You can take a color pencil and shade this entire region in. So every point that's in this shaded region and every point that's on this line is a solution to this inequality. Looking at a second problem. Now this one is not quite in standard form, but we could rewrite this in standard form as negative x plus 2y less than 6. And if we did this, our equation would be negative x plus 2y equal to 6. But it is not necessary to rewrite this inequality placing the x variable before the y variable. So we can leave the inequality as is, and then rewriting this as an equation, we'd have 2y minus x equal to 6. And I will graph this equation by finding both the x and y-intercept, where it crosses each of the axes. So it crosses the y-axis when x is equal to 0, giving us 2y minus x, so this is minus 0, equal to 6. This simplifies down to 2y equal to 6. And then solving for y, we divide both sides by 2. We end up with y equal to 3. So we have the ordered pair 0, 3. This is our y-intercept. I'll graph that point. For the x-intercept, we have y equal to 0. This gives us 2 times y, so 2 times 0 minus x equal to 6. So this is 0 minus x equal to 6, or negative x equal to 6. Then we're going to divide both sides by negative 1 to solve for x. We end up with x equal to negative 6. We have the ordered pair, negative 6, 0. And we plot that point. We now have 2 points. All you need are 2 points to draw a line. What kind of line are we going to draw? This is less than, so the line will not be included as a solution to this inequality. So to show that, we're going to use a dashed line. This dashed line is now our boundary line, dividing the graph into two regions, and then we need to determine which of these two regions contains the solutions. Let's test some points. Again, I will start with the point 0, 0. So at 0, 0, we have 2 times y, so 2 times 0 minus x, so that's minus 0 is less than 6. We have 0 minus 0 less than 6. This gives us 0 less than 6. That is a true statement. 0 is less than 6. Now this result tells us that we should be shading this section of the graph. But always test a point in both regions. One way of checking your work. In this case, let's test the point 1, 8. So testing the point 1, 8, we have 2 times y, so 2 times 8, minus x, so minus 1 less than 6. This is 16 minus 1 less than 6. We get 15 less than 6, and this is not true. And then we shade in the correct side of the graph. So for this particular inequality, the points that are on the line, on the boundary line, are not solutions. If you plug these points in to this inequality, you will not get a true statement. However, every point that's in the shaded region will give a true statement. And this is how we graph linear inequalities, showing what points are solutions to the inequality. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So the first step for graphing a linear inequality, go ahead and rewrite that inequality as an equation, and then graph the equation. Since these are in standard form, I went ahead and graphed the equation by finding 2 points, specifically the x and y-intercepts. Graphing those 2 points, we're able to draw the boundary line. In this case, the boundary line is a dashed line because we have greater than as opposed to greater than or equal to. The points on the line itself do not represent a solution. And then testing 2 points, we're able to determine that the region with the origin represents the solutions, and so we shade that region in. For this second inequality, we have x plus y greater than or equal to 4. Converted this into the equation, x plus y equal to 4. For this equation, we're able to find both the y-intercept and the x-intercept. Graphing those 2 points, we were able to draw our line. This is a solid line because the inequality was greater than or equal to. So that r equal to means that every point that's on this line, this boundary line, is a solution to the inequality. And then testing a point on either side of the line, we were able to determine which region to shade. Drop any questions you have in the comments. Continue practicing graphing linear inequalities, and I'll see you in the next video.